Hey everyone, it's Chloe here from Tutoring Your Way and I'm back for another video. So today we're going to be going through the further maths concept of bearings. This is within the module of geometry and trigonometry, so it's not going to apply to all further maths students. But when I ask students who are doing that module, what's the part you struggle with most, they say bearings. I have no idea what bearings are, how to do them, so we're going to go through them today. So a bearing is the direction or angle a line makes clockwise from north. So that's the important bit. We've done directions and angles before. We've done finding the angle within a right angle triangle. We can find angles in non-right angle triangles, but clockwise from north, that seems to be the tricky bit. So when we have a bearing from a particular point, we start at that point, we draw a line north, and north in maths is always upwards on the page. You don't have to get your compass out and find north. So we draw our line upwards for north, and then we go clockwise. So we start at north and think about clockwise, so the way a clock goes. So we go around until we hit that line or angle that we're trying to make. So for example, here we've got a bearing of 28 degrees. It's an acute angle from north. Down here we've got our point A and our line down here. So we draw our line to north, and then we go clockwise. That is the angle we're trying to find. Or say for here we've got the angle of 330. So we start at our point, we draw a line upwards north, and then again just go clockwise until we hit the line that they've given us. So here it can be super tempting to find the angle in here because it's a neat little angle. We just think that's theta, that's the angle I've got to find. But remember, we're always finding the angle clockwise from north. I can't stress that enough. So we start at north and then we go clockwise until we hit the line. So here it's going to be 330 degrees. So let's look at an example of bearings. So this question says ship A and ship B can both be seen from the lighthouse. Here's our lighthouse, here's ship A, here's ship B. Ship A is 5 kilometers from the lighthouse on a bearing of 28 degrees. Ship A is 5 kilometers from the lighthouse on a bearing of 28 degrees. So they're from the lighthouse, that's the important part. From the lighthouse. So we start at the lighthouse, they're starting from the lighthouse. They've drawn their line up north, and then they go clockwise until they hit that line, and that was 28 degrees. Always clockwise from north. Then they've gone 5 kilometers that way. Ship B is 5 kilometers from ship A on a bearing of 130. So they start from ship A, draw their line up north. No matter where the point is on the page, you always draw your line up north. Then they go clockwise 130 degrees till they hit that line. They've sailed for 5 kilometers, and then we don't know the bearing from ship B to the lighthouse. So in the previous parts of the question, we found this angle X here, and we found angle Y. So we've just popped them in there. Determine the bearing of the lighthouse from ship A. So whatever one it's from, that's the one we start at. So we're starting at ship A up here. First thing is to identify the angle that we're trying to find. So we draw our line up north, and we go clockwise from ship A until we hit the line that joins us to the lighthouse. So if I was to stop only at this line, that would be the bearing to ship B, which we've already got. But we're going all the way around to the lighthouse. So here we can see we've got an angle of 130 and we've got an angle of 78. So we can actually just add those together, and that will give us the bearing of the lighthouse from ship A. We've got 208 degrees. So that one's pretty clear cut, the information set out for us on the page. This one says determine the bearing of the lighthouse from ship B. So we start at ship B, we identify the angle, go upwards to north, which they've kindly drawn from us, and go clockwise from that line. So we go clockwise all the way around until we hit the line that joins us to the lighthouse. This is the angle we're finding. So see how we've got a full circle here. If we take away this part and this part, then whatever's left is going to be our bearing. So we start off maybe by finding this inside angle here. Say we call this one Z and this one theta. So here we've got an isosceles triangle. So an isosceles triangle, we've got 2 sides are the same and 2 angles are the same. All the angles in the triangle have to add up to 180. So we do 180. So we do 180, take away the angle we already have, gives us 102. Divide that by 2, and that gives us 51. So this one was already written here, but we know this one's now 51 as well. Now for this angle here, we can use corresponding angles. So we've got two parallel lines. We've got our north line here and our north line here, and a line running through those two parallel lines. So if we were to extend this line up here, then we know that this whole angle adds up to 180. We know this part is 130, so the last part is going to be 50. And then because we have two corresponding angles, we've got our two parallel lines and one line running through it. The angle on the left up here is going to be the same as the angle on the left down here. So our theta is going to be 50 degrees. And then if we know this whole thing, the whole circle is 360, and we take away the bits that we don't want, so we take away 50 and 51, that'll give us 259. That's our bearing. The bearing of the lighthouse from ship B is 259. So I hope you've enjoyed this video today, explaining a concept that a lot of further maths students struggle with. And if you can get this concept down pat, then you're going to be really ahead of the pack when it comes to SACs and exams. Good luck with everything, guys, and I hope to see you back here for the next video.